Let's find the area trapped between these two functions. We'll do it with numerical integration. The big thing that I want you to get out of this is how to find the points of intersection of these two curves and then use them as limits in your numerical integration. So it's a little bit of setup, it's a little bit of technology. The graphs of those two functions are right here. But let's do this on our graphing calculator. We're actually going to need to do it on our graphing calculator. We'll first find this point of intersection and then store it, and then likewise find this point of intersection. So let me go back to the dock camera over here. Let's put in those two functions into our calculator. Clear out the old stuff. 2x plus 5 and e to the x. As far as my window is concerned, I think I can probably get away with -5 to 3 on the x-axis. And let's see. How about y-axis from -1 to, let's go up to 12. Just a guess on that one. I think it's going to be more than I need. There's your linear function. Here's the exponential function. So let's start by finding the point of intersection down here somewhere between -2 and -3. So hit the second key and then the calc key, or the second key, then the trace key that takes you to the calculate menu. You want the option down here, number 5, intersect. It's going to ask you to find, a point closer to our point of intersection for the first curve. So let's trace down here until we get to a point, a little bit to the left of this, at least close enough to where they intersect, and press enter. I'll press enter again because this is the estimate for the second curve. And it wants one more estimate. You don't have to move at all. You can just press enter one last time. You should get -2.457 for your point of intersection. You guys getting that? Okay. So let's exit this. So hit the second key, then the mode key, and take your value for x, type it out, make sure that it is what we think it is, and then hit the store key. Let's store that in, say, variable a. So store key is down here, so store, and then up here for alpha, and then the math menu gives you a. So now that's stored in a. Cool. Let's go back and find the other point of intersection. Let's go to your graph. Let's repeat these steps to find that point of intersection over here, somewhere around 2. As before, second, and then the trace key takes you to this menu. Fifth option down is the intersection. First curve, well, it's going to be someplace over here near 2. I think that's close enough. Second curve, I'll get a little bit closer. You don't have to. Final guess gives us a point of intersection of 2.25. Good enough. Is everyone able to get 2.25? Boy, there's something wrong with that one. yeah. Come see me with that one. Here, you can borrow a different one if you'd like. Let's quit this. If you type X, you should be able to see that new point of intersection, 2.25. Now we're ready to integrate. So hit the math key. Okay, that's because I threatened it. Math 9, fn int. We want to go from our lower limit, which is a, so hit alpha a, to the upper limit, which is still an x. Now x is going to get a lot of work done for us in this case because I'm just going to type in my function defined in terms of x. You could use y here or any other variable on your keyboard. I'm just going to use x because x is, you don't have to hit the second key to get to the x or the alpha key to get to the x. So it was 2x plus 5 minus e to the x. And all that is dx. So you should get about 13.15, etc. All right, Mir, well done. Yes, sir. You're messing with me.
I am not learning like that. Like everything was working.
So the error is someplace between the calculator and the chair? He missed that. All right. Well, come see me afterwards. But you should get, about the 13.1586. One other thing that you could do here, if you've already got your functions typed in, then kind of a faster way to do this would be to hit the math key and then 9. Let me type in a to x as before, except this time I'm going to type in y1 minus y2. And somebody in my morning class reminded me that there's a faster way to get to y1, and that is if you hit the alpha key, then the trace key, and there's y1 minus alpha trace, and then the number 2. Now we're still going to integrate with respect to x. Yay! So a little bit faster if you've already got these typed in, then you don't have to type it in again. That's especially convenient if you change your functions. If you have the same interval, then you can just retype that command by changing your functions. You get a different interval. All set on this one? Any other wrap-up? Questions, comments?
I don't really gotta know how I got 0.
Did it work out this time? All right, come see me. Good luck with this. Make sure you're ready for something similar to this on an exam where you're going to have to find at least one of your limits of integration as an intersection point and then use that in your numerical integration. Good luck. See ya.